And this will show the calibration of the drop counter. And let's go take a look. This shows a big syringe with a couple of valves, and this is going to have the sodium hydroxide in it. This is the drop counter, and you could see that it's indeed the drop counter. And what it's going to do is it's going to count drops as they drop from the syringe. And to calibrate it, we're going to count the number of drops to get a certain volume in the graduated cylinder. And that will be saved in our friend the LabQuest. So when we do a titration, it'll count drops and convert that into volume. So I'm going to click and calibrate. And let's see, add titrant dropwise through the drop counter into the 10 milliliter graduated cylinder. So up here, now this bottom valve is just going to be a on-off valve. So right now it's open. And I'm going to open the top valve until it starts dripping at a decent rate. And I'm going to leave that top valve, once I got it set, I'm not going to touch it anymore. I'll just use the bottom valve as a on-off. And we're going to be measuring the volume in the graduated cylinder. And I want about this thing to be about full. So I'm going to turn it off when we get to 9-something milliliters. And it's waiting for me to open the bottom valve. And you should see that red light flashing when the drops start dropping. And here you can see the drops dropping and the light flashing as the drops break the beam of light. And here you can see the drops being counted. And all I have to do is turn off the valve and it'll stop counting, and then I enter in a volume. And here I've entered in the volume. So it took 196 drops to get 9.8 milliliters. And this is the titration of the acetic acid. This should take about 20 milliliters of the sodium hydroxide. And let's see, let's just there you go. There's the flask with the pH meter and the stir bar. And the directions say that the stir bar shouldn't be hitting the pH meter. It is hitting the pH meter. The pH meter has a glass bulb at the bottom that's very fragile, but it's got plastic feet around it, so to help protect it. And what you're actually measuring in this experiment is voltage between the inside the glass bulb. There's a liquid in there, and outside the glass bulb there's the acid solution with the changing pH. And so that voltage is converted into a pH. And I'm just going to keep on recording and see if we can see the change in color. There's I can see a little bit of the pink color of the phenolphthalein that quickly fades as the solution is stirred. And let's see, plan ahead. There you go. And looks to me like it's pretty close to the equivalence point. pH is 5.9. The equivalence point is going to be a little bit higher than 7. And now we have a rich magenta color. And the pH is shot up to 11.5. This shows an example titration curve of formic acid titrated with sodium hydroxide. Now, several of the points you're going to be interested in. One of these is the endpoint. Now, little experimental errors in this data, like there looks like there's a little bump here, and so it looks like the curve kind of has too much of a slope and then it kind of goes back. And so what you're going to see is this area down here, the slope is too high and then the slope is too low. And so it kind of makes this curve a little bit ugly. And you don't always want to use just the peak of this first derivative. Keep an eye on this curve because the endpoint is going to be right about in the middle. And so you probably want the middle of this curve. Now, up here, you're going to want that volume. Now, with that volume, you can calculate the concentration of the formic acid. But also at that volume, that's the volume to the endpoint, 1/2 that volume. Now that looks like it's going to be 9.2 or something like that. So maybe 4.1, that's going to be 1/2 of the endpoint. And your professor will tell you that's a special point, and that's something that you're going to use to calculate the ionization constant. Also over here, this doesn't depend upon determining the endpoint, but you can use this initial pH to calculate a ionization constant.